Hi, I'm Evan Gardner.
And I'm Hannah Risker.
And today we're going to be going over food packaging and polymers.
Today, one of the things that we're going to be doing is we're going to be looking at snacks such as chips and a candy bar wrapper. We're going to determine the layers that make up the wrapper.
We're also going to be measuring the volume that juice and soda bottles can contain and see how that changes by dumping boiling water on it.
So let's
get started.
Okay, so we have our chip bag, and we've already cut it to where we'd be able to see the layers. And so whenever you're looking at the chip bag, to the human eye, you would think that it has about 2 or 3 layers, because there's the purple packaging. And then, as you can see under here, there is some foil, but then we peeled back the foil a little bit, and we saw that there was a small looks kind of like a little bit of a white layer, and we could tell that that comes up, so we think that that might be an adhesive to keep this foil with the packaging.
Alright, so now we are going to shine a flashlight through the packaging with the tin side facing us, and we're going to see if we can see the printing of the packaging. Not sure if the camera will pick that up, but you can see it, like right where the flashlight's shining. So now we're going to draw an A on the foil side. We are going to shine the flashlight for the tin foil side and look at it from the labeling side, the print side, and see if we can see the A. You can see the letter A through the bag and all the layers. Since we can see the A on the print side of the package, we both think that it is not made with aluminum. We don't think there's aluminum in the packaging because I think that the light would reflect off of the aluminum side and it wouldn't be able to pass through to the other side. So I don't think we'd be able to see the A if this was made out of aluminum. Okay, so we're examining our candy bar wrapper now, and what it looks like is it doesn't look like there's much of anything on the side. It just looks like the back side of the print, and it feels like there's an adhesive layer along the side to keep it sealed off. So it looks like it's only got 2 layers if I had to guess, because you don't even have to shine a light through to see the pack or the labeling or anything. It just looks like there's the print side, and then they fold it up and seal the sides of it with adhesives to keep it sealed off. Now we're going to see if there's enough air in this package to help this float in the water, or if we're going to see if it sinks or not. So now we are going to determine the volume of both of these containers by we filled them up with water, and we're going to pour them into this and count how many, basically 100 milliliters we end up dumping out of each one. And we're going to record this process several times.
So now we're going to pour this boiling water onto the water bottles and see what happens. We are now pouring water back into the bottles so that way we can measure the volume after we poured boiling water on them.
Right on the spot. As you can see, after we poured the boiling water over this 2-liter Coke bottle, it shrank. You can tell by this paper that was wrapped around it. It shrank a lot. You can see there by how much extra we have. And this juice bottle actually, when we poured boiling water on it, it heated up on the inside and it swelled up. And now it's holding more than it was before. And so it didn't shrink like this one did, even though they're the same plastic. But so that's what happened when we dumped boiling water on each of our 2 bottles.
We hope you not only enjoyed this lab, but we hope that you learned something.
We hope you stop by for next week's lab. It's good to talk trash. We'll see you next time.